Hi everyone, let us discuss how to perform speed control of a three-phase induction motor by various methods like rheostatic control, autotransformer, etc. Objectives. At the end of this video, you will be able to connect the three-phase slip-ring induction motor through the rotor resistance starter, control the speed of a three-phase slipping motor by rotor resistance starter, connect a three-phase induction motor to an auto transformer starter, control the speed of a three-phase induction motor by an auto transformer starter. Let us discuss on speed control techniques on three-phase induction motor.
Let us collect the tools, equipments, and machines required to do this practice.
Insulating cutting pliers 200 mm, 1 number. Connected screwdriver 100 mm, 1 number. Electrician's knife 100 mm, 1 number. Screwdriver 200 mm, 1 number. MI voltmeter 0 to 500 volt, 1 number. Tachometer 300 rpm to 3000 rpm, 1 number. Megger 500 volt, 1 number. Three-phase slip-ring induction motor 415 volt, 3 HP. Rotor resistance starter complete set suitable for 3 HP. AC three-phase squirrel cage induction motor 500 volt, 5 HP. Auto transformer starter complete set suitable for 5 HP. PVC insulated flexible cable 2.5 square mm, 20 meter. ICTP switch 10 ampere 500 volt, 2 number. Test lamp 40 watts, 250 volt, 1 number. Procedure. Task 1. Control the speed of a slip-ring induction motor by a rotor resistance starter. Check the insulation and continuity of the motor winding. Set the megger to the appropriate voltage range for testing insulation resistance. Typically, a test voltage of 500 volt is used for low voltage motors. Disconnect all the motor leads from the power supply and any other connected devices such as motor protection devices or contactors. Continuity test. Connect one lead of the megger to a known good ground point such as motor frame and use the other lead to test the continuity between each pair of motor winding terminals. The megger should indicate a low resistance or continuity for each winding. If there is an open circuit or a significantly higher resistance, there may be a broken conductor or a faulty connection. Make the connection as per circuit diagram. Connect the DOL starter to the motor stator terminals. DOL starter. It consists of a contactor, overload relay, and control circuitry. Identify the motor terminals. The motor will have 6 terminals labeled U1, U2, V1, V2, W1 and W2. U1, V1 and W1 are typically the incoming terminals, while U2, V2 and W2 are the outgoing terminals. Connect the control circuit. The contactor will have specific terminals for the control circuit. These are usually labeled A1 and A2 or coil on the contactor. A1 is for the positive side of the control circuit and A2 is for the negative side. Connect the start and stop push buttons in series with the control circuit. Use control cables to connect one terminal of the start push button to the positive side of the control circuit. Example, A1 on the contactor, and the other terminal to the negative side of the control circuit. Example, A2 to the contactor. Repeat the same for the stop button. For added safety, you can implement coil interlocking to prevent both the start and stop push buttons from being active simultaneously. Connect a normally closed contact of the stop push button in series with the start push button and vice versa. This means that when one push button is pressed and the other cannot be activated until the first one is released. Connect the rotor resistance to the rotor side of the slip ring induction motor. Identify the rotor terminals on the slip ring induction motor. These are typically found in a terminal box on the motor. Connect the resistors of the rotor resistance starter to the rotor terminals of a motor. Keep the rotor resistance starter handle in the starting position. Cut-in of the rotor resistance. Cut-in position of the rotor resistance is generally indicated in the starter as starting position or off position. Press the start button of the starter. While pressing the start push button, slowly move the handle of the rotor resistance from the starting position towards the running position step by step till it settles down at run position. Measure the speed at every step of rotor resistance and record. Release the pressure from the start push button. Press the off button of the starter to stop the motor. Control the speed of three-phase induction motor by an auto transformer starter. Make connections as per diagram. Identify the three-phase motor terminals labeled U, V and W. Connect the primary side of the auto transformer to the power supply. Connect the secondary side of the auto transformer to the motor terminals U, V and W. Connect the control circuit with start and stop push button switches. Ensure the knob of the three-phase auto transformer is at the minimum position. Switch on the main switch S1 and then press start push button. Keep auto transformer for 100 volt output. Start moving the auto transformer starter contacts such that the induction motor will start getting more voltage in stages up to full voltage. Note the speed and voltage at every stage. Reduce the applied voltage to the induction motor by resetting the auto transformer contacts. Measure the RPM of the induction motor at every stage and note in tabulation. Switch off by pressing stop button and then switch off the main switch S1. Conclusion. State in what proportion the speed changes with respect to applied voltage to induction motor. Recap. In this video, so far we have discussed how to control the speed of a slip ring induction motor using rotor resistance starter and squirrel cage induction motor using auto transformer starter. Thank you for watching. Have a good day.